This is a Phanotron bulb. Here we have a Lenco F-2800 frequency detector, currently set to the 300 megahertz range. And every time there's a red flashing light, we get a frequency readout, so we're picking up a carrier frequency. And on the bottom you can see some power bars which indicate the strength of the signal. As I move closer to the Phanotron, you see the signal strength increase. And here we have almost at the microscope here. See the relationship. I'm standing about 2 feet behind the microscope. We're actually picking up 27 megahertz here. F125 frequency generator, we're feeding in a steady 924 hertz. Now I'm standing about 4 or 5 feet away on the back side of the Phanotron. We're still picking up a pretty good radio frequency signal. I don't understand why that frequency number keeps changing though. It's a little bit strange. Now we're aiming right at the Phanotron. You can see here in the background. The antenna is maybe 2.5, 3 feet away max. You see a maximum strength of the radio signal. And we are coming out 28 megahertz, 27 megahertz. So it seems like if you want to get an accurate reading of the frequency coming off of that, well, now we see it climb sometimes. We have about 80 watts, SWR just below 1.2. Now standing to the side of the Phanotron, let's see what we pick up. 28 megahertz. Let's come right, put the antenna right next to the Phanotron, 6 inches away. 28.5 megahertz. Now we'll come around the other side of the microscope, by the microscope stage, and see what we pick up over here. .25 megahertz. On the other side of the microscope. As we get really close to the Phanotron, the tip of the detector antenna is just 3 inches away or so. It's much more consistent, around 27, 28 megahertz. So let's go left of the Phanotron, right next to the bulb. A very powerful radio frequency signal. 29 megahertz. If I get too close, I risk damaging the device. I will back off a little bit, 1 foot away. It's very powerful signals coming off the back of the Phanotron. You see my detector antenna here. Now this is strange. Coming off the back side, notice all the electrodes are arranged here. And coming off the back side, we seem to get different carriers over here. Look at that. Powerful radio signal and a carrier of 43 megahertz. You get closer to the device, Interesting. The amplitude input signal, modulating signal, is steady at 924 hertz. Now we're back over on the other side, and we're back in the 29, 28 megahertz range, right over the slide. 29. Now we're feeding in about 2,880 hertz. Got about 90 watts, SWR just under 1.2. That took quite a while to tune, too. Okay, we're on the right side of the microscope. We're going to measure some frequencies here. Pretty good. 28 megahertz. Kind of what you'd expect, pretty close. Now the antenna is to the side of the Phanotron, like that. 27 megahertz. Now we're on the back side of the Phanotron. And look what happens. About 4 inches away. Here's the antenna. Maybe 5-6 inches away. And the Phanotron on the back side. Look at that. 32, 33 megahertz. Powerful signal. If I get really close, I still get, never really get 27. As I move a little farther back, just about the antenna is about 1 foot. The antenna of the detector is about 1 foot from the Phanotron. Look at that. 43 megahertz. 44 megahertz. Interesting. A little farther away, 3.5 feet from the Phanotron. 43 megahertz on the back side of the Phanotron. Interesting. Okay, now we're feeding 10,000 hertz into the Phanotron. Into the OM1, actually. Here I'm standing in front of the Phanotron. The antenna is maybe a foot above, 2 feet, 2.5 feet above. Let's lower the antenna of the detector. We're sort of on the side of the Phanotron. Now we'll go to just to the right of the microscope with the detector antenna. And we read 26 something megahertz. I'm right above the microscope stage. We're getting 27 megahertz there. Now we're going to go to the back side, the left side of the Phanotron. I think the frequency just changed. Now we're going to go to the back side of the Phanotron. We're feeding in 10,000 hertz. And the antenna is about 6-7 inches away to the left of the Phanotron. And we're picking up 35 megahertz. Raise the antenna up a little bit. You get 27 megahertz. Lower the antenna back down. It's now parallel with the plane of the Phanotron. You get 35 megahertz. Now we'll move a little farther away. Now we're moving, we're about 2 feet to the left of the Phanotron on the same plane as the Phanotron. 39 megahertz. Pretty steady 39 megahertz. Now we'll step back about 5 feet to the left side of the Phanotron on the same plane, 35 megahertz. Now I've raised the antenna up above the Phanotron at an angle, 5 feet to the left, 30 megahertz. And here I am, considerably higher, about 2.5 feet to the left, but pointing the antenna out, up and above the Phanotron, receiving 26 megahertz. But as I lower the detector antenna, I read 38 megahertz. Now I'm getting a little closer. Here I am on the plane of the Phanotron, 38 megahertz. Now I go up a few inches, and it drops down to 27 megahertz. And here I am over on the other side, away. I'm in front of the microscope to the right, and the antenna is, 3.5, 4 feet in front and off to the side on an arc. And we're picking up a low signal here of 43 megahertz, but that's not, I don't think that's reliable. We need to have a good strong signal. There you go, 26 megahertz. And the frequency just changed to around 3080 hertz on the F125. So we might be getting different carriers coming out of the Phanotron. Now it occurs to me maybe the length of the antenna on the detector makes a difference. Here I am next to the microscope, picking up a strong signal which it says is around 18 megahertz. Now I extend the antenna about halfway on the detector, picking up 43 megahertz. Hold on, I don't think it's set right, just a minute. Oops. Sorry. Now with the antenna about halfway out, I pick up 25 megahertz. Let's push the antenna back in. The antenna is in, and you read 18 megahertz. Here we are next to the stage of the microscope, 19 megahertz, 18, signal drops off. Now I've extended the detector antenna fully, which is 3 feet maybe, and we'll slowly approach the microscope. And you see the signal level shooting up. And we're coming in 26, almost 27 megahertz. I'll put the antenna right by the stage of the microscope. Yep, we pick up 28 megahertz. Now let's go to the back side, left side of the Phanotron. Let's see what we pick up right next to it, 31 megahertz. That's about 3 inches away. Now I just raise that vertically. Drops down to 27. Now I'll raise the antenna straight up. See what it picks up. 24 megahertz. Back down, very strong signal. 27 megahertz. And now parallel to the plane of the Phanotron. Interestingly, we always seem to get in the 30s, 36 megahertz. Now on the same plane, moving a little to the left, now my antenna is 3 feet left of the Phanotron. We read a powerful signal at 39 megahertz. I raise vertically the antenna, and we seem to get back up to the 27. So right behind the Phanotron, to the left of those electrodes, we seem to have a very high carrier frequency. There we go. And what's being transmitted now The broadcast on the F125 is 2,490 hertz. And standing right next to the F125, so when I raise the antenna vertically on about must be 50 degree, 55 degree plane from a parallel plane with a phanotron, I do pick up a carrier of 27, 28 megahertz, but as I drop the antenna flat, parallel to the plane of the phanotron, I pick up those carriers in the high 30s. Interesting phenomenon of what radio frequencies are coming off this phanotron tube here.